in the last class, we have started the areas of a triangle. Okay, and I have given some questions from this PPT also, and some questions I have given from the assignments. Okay, so this we have already completed. Okay, so I hope I have given this question. So anyone have a doubt the questions from this slide, from this PPT? Anyone have a doubt? Okay, Shravya, you have just joined. You have completed the homework, Shravya?
Yes, a bit.
Okay.
2 or 3 questions are left.
Okay, Shravya, any doubt?
No, sir, but then I was not there for the previous.
Sorry?
So I wasn't there for the previous class.
You were not present in the previous class. Okay. Okay, Shravya, then we will complete this topic later on. Okay, we have already started the area of a triangle. And Shravya, when you have your exams?
So it starts from May 19th.
May 19th. Okay, and what's the syllabus?
So could you repeat?
Yes. What is the syllabus? How many chapters are coming?
So relation function, inverse trigonometry, and derivatives till second derivative.
And derivative. And they are not. They have not started the matrices and determinants.
No, sir. We'll be starting after Eid holidays.
Okay, so from 19th May you have exam, and the syllabus is relations, inverse, and derivatives. Complete continuity and differentiability. Huh?
No, so only till second derivatives.
Okay, so continuity they have not started.
No, we have not started continuity.
Okay. Okay, complete. So hopefully till tomorrow we will complete this chapter. Okay.
Yes.
So this question I have given the homework. So hopefully everyone can complete this. Okay, you will not face any issue in this question. There's a very simple one. Okay, we will start with the next one. Yeah, there's a good question. This question is from NCERT exemplar. So I will give you only 5 minutes. Please try to do this question and let me know if anyone is facing issue in this one. Or let me solve this for you. So in this question we have 3 coordinates, and these are the vertices of a triangle whose side is equal to A. Okay, triangle is equilateral triangle. Side is given. We need to prove this. Okay, so everyone know that area of triangle. Just give me a minute. Area of triangle is equal to, okay, we will represent this by del, and this is equal to 1 by 2 x1 x2 x3 y1 y2 y3 and 1 1 and 1. Okay, this is the formula for the area of the triangle. Now, what about the standard formula? If we have an equilateral triangle, then and a side is A, then anyone can tell me what is the area of equilateral triangle? You have done this formula in your previous classes, in class 8 or 9. Area of equilateral triangle. Anyone can tell me?
Root 3 square by 4.
Very good. Who was this? Atif?
Yes.
Okay, great. Root 3 by 4 A square. Okay, where A is the side of the triangle. So we have this formula. This we have done in class 12. This is the formula of determinants. And this is our basic formula that area of triangle is given by root 3 by 4 A square. Now we need to prove this one. Okay, we need to prove this is equal to 3a to the power 4. So we know that from where we will get this? We get this from this formula. Now both are areas. Both are the areas, so that means we can equate these two. Okay, so we can say that 1 by 2, this x1, y1, 1, x2, y2, 1, x3, y3, 1. Okay, this is equal to root 3 by 4 a square. Okay, hope this point is clear to everyone, that from this we have an area of the triangle, and this is also the area of a triangle. So both are the areas, that's why we can equate these. Okay, now what you can do, shift this 4 to the left side to this one. So you will get here 4 by 2. Okay, this is x1, this is x1, x2, x3, y1, y2, y3, and 1, 1, 1. And this is equal to root 3. This is equal to root 3a square. Okay, now divide this 4 with 2. Divide this one, so you will get 2. 2 into x1, x2, x3, y1, y2, y3, and 1, 1, and 1. And this is equal to, root 3a square. Now, anyone can tell me, if we will multiply this 2 with the determinants, then what the value we will get? Atif, can you tell me? If you are multiplying the complete determinant by 2, then what the value we will get? Atif?
So it will be 2 raised to 3 into the value of the determinant.
Will you please repeat?
So 2 raised to 3 into the value of the determinant.
No. We are multiplying the complete determinant with 2. Anyone else? Shravya, can you tell me? If you are multiplying this
Sir,
determinant
everything will get multiplied by 2.
with, you mean to say all the elements will get multiplied with 2?
Yes, sir.
No, I'm sorry, that's not correct. Anyone else? Abdur? If you are multiplying the complete determinant with 2, then can you tell me what the answer we will get?
So 2.
2 means you will multiply all the elements of this determinant with 2?
No, sir, only the starting 3 elements.
Starting 3 elements means starting row.
Yes, sir.
Okay, let me check with others also. Mazia, if you are multiplying this determinant with 2, then what the value you will get? Mazia, do we need to multiply all the elements with 2, or any particular row or column will get multiplied with 2? Mazia, my voice is audible. Mazia, yes or no? Mazia, we can't hear you. Next, Saf. Saf, if you are multiplying this matrix with 2, then what will happen? Do we need to multiply all the elements with 2, or any particular row or column will get multiplied? Sorry, sir, I can't hear you. Any particular row or column will get multiplied, or complete matrix, or complete, or all the elements will get multiplied with 2? All elements. Okay. Now, please remember who has given that answer. Abdur. Abdur answer was correct. And everyone, please remember one point. This is the main difference between the determinants and the matrices. If you are multiplying a constant with a determinant, or any value with a determinant, then only one particular row or column will get multiplied with 2. So it's your choice. You can multiply any of the row or any of the column. So this is my choice. I'm multiplying the last column with 2. Okay, and remaining elements will remain the same. Okay, please remember this point. If you are multiplying a determinant by any constant or any number, then only a particular row or a particular column get multiplied with that number. It's your choice. Okay, so I have multiplied the last column with 2. Okay, and this is the difference between the determinants in the matrix. Suppose if we have a matrix, same matrix, x1, x2, x3, y1, y2, y3, and 1, 1, 1. So if we are multiplying a matrix with the 2, then all the elements will get multiplied with that number. If you're multiplying this with 2, then the answer you will get this one: 2x1, 2x2, 2x3, 2y1, 2y2, 2y3, 2, 2, 2. Okay, so I hope this is clear to everyone. This is the difference between the matrix and the determinant. If there is a matrix and you are multiplying with that any number, then all the numbers, all the elements will get multiplied with that number. If you're multiplying a determinant by a number, then only a particular row or a particular column will get multiplied with that number. It's your choice. Which row, with which row you will multiply this number. Okay, so I'm multiplying this, the last column, with 2 because this is given in the question. This we need to prove. That's why I multiply the last column with 2, and this is equal to root 3a square. Okay, now please check the proof, and anyone, okay, this is a square. This 2 in the question, this 2 means this is a square. Okay, here the 2 is over here. You can write like this. Okay, now can anyone tell me the last step? How can we prove this?
Square both sides.
So taking square on root 3 is.
Yes, perfect. Taking a square on both sides. Okay, now the last step is just do the square on both sides and you will get the same result. Okay, so just last step, squaring both sides. Okay, I will write over here, squaring both sides, and we will get this one: x1, x2, x3, y1, y2, y3, 2, 2, and 2 square. This is equal to 3a to the power 4. Okay, so I hope this question is clear to everyone. So please note down this, and if anyone have a doubt, then please let me know. Okay, and this is a very important point about the multiplication of a number with a determinant in the matrix. So please remember this point: in a matrix, all the elements will get multiplied with that number. And in a determinant, only a particular row or a column will get multiplied with that. Okay. So please put down this, confirm me on the chat box so that we can start the next topic. Okay, Javier, good. Okay, Atif, good. Maziha, Abdur, Saf, please confirm so that we can start the next question. Okay, Saf, very good. Abdur and Maziha, please confirm. Okay, Abdur, great. Maziha, shall we start next? Maziha, shall we start next topic? Maziha, will you please reply me on the chat box? Your voice is not audible. Okay, good. Now, this area topic is completed. Okay, if anyone have a doubt, then we can discuss that at the end of the class. And I hope everyone has completed the homework. If not, then please complete it today. Okay, next one. Next topic is minor. Now, what is a minor? Minor of an element Aij of a determinant is the determinant obtained by deleting its ith and jth column in which element Aij lies. Okay, so what's a minor? Minor of an element is the determinant obtained by deleting its ith row and jth column. Okay, right here ith row, okay, and jth column. Then what is meant by this one? We will take example. Suppose we have a determinant. We have a determinant like this: 1, 2, 3, 4. Okay. Now suppose you need to find the minor of this, minor of 4. Then what you will do in this determinant, you will ignore this row and you will remove this column. Okay. What you need to do, if you need to find the element, if you need to find a minor of an element, then remove that row and column to which this element belongs and write the remaining term. So remaining element is 1. This is your answer. I hope this is clear to everyone. If you need to find the minor of an element, then please from the determinant, remove that row and column to which that element belongs. We will take one more example. Suppose we have a determinant B, which is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Suppose if we need to find the minor of this one, then what we will do, we will remove this row, we will remove this one. Okay, then remaining what we will get? This one, remaining element 5, 6, 8, 9. Now here what we need to do, just cross multiply, just solve this determinant and you will get your answer. So this will give you 45 minus 48. So this is equal to minus 3. Okay, so that means if you have a determinant of order 3, then in that case you will get one more determinant of order 2 and you need to solve it. If you have a determinant of order 2, then here you will directly get the value. This is clear to everyone. There's no need to note down this example. This is clear to everyone. How you need to find the minor. Okay, good. Okay, Atif, good. Abdur, Mazia, Saf.
Yes, sir.
Okay, good, Abdur. Mazia and Saf. Okay, Saf, good. Mazia, this is clear. Okay, Mazia, very good. Then first of all, please note down this tab.
Sir,
Yes.
we can delete any one row and any one column.
Sorry, Shavya, will you repeat?
So for minors, can we delete any one row or any one column?
No, not anyone. We will delete only that row and column to which that element belong. For example, if we need to find the minor of 6, then what we will do, we will remove this row and we will remove this column because this row and this column belongs to this element. Now we will write the remaining element. Okay, remaining is 1
So
plus
it
7.
depends upon that element.
Yes, that depends on the element.
Yes.
Okay. Okay, so we will discuss this again. So minor of an element is the determinant obtained by deleting its ith row and jth column. This is ith row and jth column. Minor is denoted by Mij. So whenever you will find the minor of an element, you will denote that with Mij. So for example, if we have this determinant 1, 2, 3, 4, 5, and we are finding this minor for element 2, then we will write this element is what? First or second column. We will write M12. And what will be the value? Remove this column and this row, you will get this 3. Okay. So minor is denoted by Mij. What is I and J? That denote the row and the column to which that element belong. So I hope this is also clear to everyone, this point. Okay, everyone, please let me know if you have any problem. Now, next point is minor of an element of a determinant of order n is greater than or equal to is a determinant of order n minus 1. We will understand this with the same example. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, here if we need to find the minor of this element 2, then we will remove this row, we will remove this column, and we will write the remaining elements. Now, Atif, what is the order of this determinant?
2 by
This one, original one.
3 by 3.
3. Good. What is the order of this determinant?
2.
2. So what is happening if you're finding the minor of any element, then the determinant which we will get in the end have the order 1 less than the original one. So if the determinant here have the order 3, then for this one, so we are finding for the M12. So for this one, we will get the order 2. So always the order will reduce by 1. This point is clear to everyone? This remark?
Yes, sir.
Yes.
Okay, good. Abdur, Mazia, Saf, this point is clear?
Yes, sir.
Okay, very good. Mazia and Saf, this is clear? Okay, Saf, this point is clear, the last one? Okay, very good. Okay, then please note down this and confirm me, then we will try a question on the basis of this one. Okay.
So for square matrices of order 1, does determinant exist?
Yeah, very good question. If we have a matrix of order 1, then its minor will not exist. Your question is about the minor or determinant?
I mean minor, sir.
Minor, yes. Minor will not exist. Okay, that's why we have written over here and is greater than equal to 2. Okay, so that means we will find the minor of a determinant which have the order greater than equal to 2. So 1 will not include over here.
Okay, sir.
Everyone, please confirm me if it's okay. Shravya, I got your message. All the other students, please confirm me if it is done. Then we will start a question on the basis of this topic. Okay, Abdur, very good. Okay, Maziha, Atif, Saf, please confirm if it is done. Okay, Maziha, very good. Okay, Atif, good. Saf, this is done. Saf, shall we start next? Saf, shall we start next? This is done. Okay, very good. Next one. Please try this question. Find the minor of an element 6 in the determinant. Okay, so if you will check this, then this belongs to the second row and third column. So that means this element is A23. So you need to find M23. Please find this value and share your answer. Okay, Shravya, you are getting 7. So let me check. No, Shravya, this is not correct. Shravya, please again check your answer. Very good, Abdur. This is correct. Good, Atif. This is correct. Shravya, very good. Now it is correct. Saf and Mazia, please share your answer if this is done. Okay, Mazia, what's the answer you're getting? Saf, what is the answer for this? No, this is not correct. Okay, Saf, but you need to find the final answer. Okay, Mazia, what is the answer? Mazia, what is the answer for this? Saf, please check here. So this element 6 belongs to this row. Remove this column. Write the remaining elements. Okay, but you need to solve that. So you get 1, 2, 7, 8. Now here cross multiply this 8 minus 14. So this is equal to minus 6. Okay, Saf. This is clear.
Yes, sir.
Okay, very good. Mazia, this is clear. The same answer you're getting. Okay, very good. Okay, then we will start the next topic. Next is cofactor. Okay, we have done that. What is a minor? Next, the topic is cofactor. Now, cofactor of an element denoted by aij. Okay, if you have an element this, then its cofactor will be denoted by aij. Minor is denoted by mij. Cofactor is denoted by aij, and this is what. And it is given by -1 I plus j mij, where mij is a minor of aij. So what does that mean? We will take example. For example, if we have a matrix B, okay, and this matrix is 2, 3, 2, 3, 4, 5. Okay, so its determinant is what? Determinant is 2, 3, 4, 5. Okay, sorry, this sign. Okay. Now, anyone can tell me what is the value of M11?
5.
5.
5.
Okay, M11 is 5. We will remove the first row and the first column. We get a 5. Now, what is a cofactor? Cofactor is denoted by A11. If minor is M11, then the cofactor will be denoted by A11, and this is equal to -1 to the power sum of these two numbers, 1 plus 1, and multiply this with the minor. So what you will get over here, -1 to the power 2 is again positive, mij is 5. You will again get the same answer for this case. So how you need to find the cofactor? First find the minor and multiply the minor with this number, -1 to the power I plus j. Whenever you will multiply the minor with this, you will get the cofactor. This is clear? Atif, Abdur, Mazia, Saf, Shravya.
Yes.
Okay, very good. Atif, Abdur, Mazia, and
Yes, sir.
Saf.
Yes.
Oh, okay. Okay, Mazia. Okay, Saf. Very good. So please note down this, confirm me, then we will try some questions on the basis of this topic. Okay. Okay, Shravya, very good. Everyone, Atif, Abdur, Mazia, Saf, please confirm. Okay, Atif, good. Abdur and Saf, this done. Abdur, Saf, and Mazia, this done. Shall we start next? Okay, Mazia, very good. Saf and Abdur. Okay, Saf, I got your message. Abdur, this is done. Shall we start next? Okay. Next one. Next question is find the minor and cofactor of all the elements of the determinant. Okay, there are 4 elements. You need to find the minor and cofactor of all these elements. Please try this one. Shravya, very good. Okay, Shravya, this is correct. M11 is 3. And A11 is also then is equal to 3. Good. Good, Shravya, this is correct. Very good, this is correct, Shravya. Okay, M21, this is correct. Good. Shravya, why A21 is 6? If
Typing mistakes, I'll send the answer.
okay, no issue. Everyone, Shravya, this is correct. Good. Everyone, you can share your answer if this question is done. Okay, Atif. M11 is 3. I will write the answer over here. Okay, M12, first row, second column is 4. Good. M21, second row, first column is -2. M22 is 1. Very good. And here we will get this equal to -4. A21 is equal to 2 and A22 is equal to 1. Good, Atif. This is correct. Very good. Shravya, this is correct. Good. Abdur, Mazia and staff, please check the answer. Are you getting the same one? Okay, Mazia, very good. Okay, Saf, very good. Abdur, A12. Okay, Abdur. Abdur, what the value you are getting for M12? If we will check this one, okay, first row, second column. So we get what? 4. Now, what is A12? As per our formula, this is equal to -1 to the power sum of these two numbers, 1 plus 2 into M12. So this we will get minus M12. Okay, now M12 is 4, so that's why this we will get -4. This is clear, Abdur?
Yes, sir.
Okay, very good. Then Abdur, this is done. Shall we start next? Abdur, please note down this answer and confirm me so that we can start the next question. Okay, good. Now please note down some notes. Okay. The first note is sum of the product of any product of element of any row or column with their corresponding cofactor is equal to the determinant. Okay. So what does this mean? Determinant is equal to, okay, this is the sign of determinant. If you are finding a determinant, then this is equal to sum of the product of element of any row or column. Okay, product of any row. So for example, if I'm taking a elements of first row, we will take this determinant a11, a12, a13, a21, a22, a23, a31, a32, a31, a32, a33. Okay, this determinant we get. Now if we have selected the first row, and we are multiplying this first row with a cofactor of the same row, that means a11, a12, a13, and if we will add these one, then we will get the value of the determinant. This clear? This clear to everyone? If we have taken any row or column and we have multiplied the elements of that row or column with a cofactor, then we will get the determinant. This clear?
Yes.
Okay. Mazia, Saf, Shravya, Abdur. This clear? This point is clear? Okay, Mazia. Okay, Saf. Abdur, this clear? Abdur, this point is clear. Abdur, this point is clear. No reply, huh? Okay, so everyone please check this. If we have selected the elements of the second row, A21, A22, A23. Okay, if we have selected A21, A22, A23, and we are multiplying this with a cofactor, its own cofactor, then anyone can tell me what we will get?
What is it? Can you repeat?
Yes, I'm saying if we have selected elements of second row, this is the element of second row, and we are multiplying this with a cofactor of the second row. Okay, then can you tell me what the answer we will get? Shravya, Atif, Abdur, Mazia, Saf. What the answer we will get? No, this will be equal to the determinant. Please check the first note. What is the first note? Sum of the product of any element of any row or column with their corresponding cofactor. Okay. So if you are multiplying the elements of any row or column with its own cofactor, then you will get the value of the determinant. You know how to solve this determinant. Okay, that value will be equal to this one. Now this point is clear. The second one. Everyone please reply me on the chat box, okay? So that I know that you understood this.
So here we're multiplying the particular element with a cofactor, corresponding cofactor.
Yes, with its own cofactor, then you will get the value of the determinant.
Understood.
Okay. Okay, Shravya, good. Okay, Mazia, I got your message. Atif, Abdur, Saf, this point is clear.
Yes, sir.
Okay, then if I will select the third row, A31, A32, A33, and we are multiplying this with a cofactor A31, A32, A33, and if we will add it, then what we will get?
Determinant.
Again, determinant. We have selected the third row, we have multiplied with its own cofactor, so we will again get the determinant, again get the value of the determinant. Now suppose if we have selected the first column, A11, A21, A31, and if we multiply this with A11, its own cofactor, then what will be the answer? Again determinant, again the value of the determinant. Okay, so I hope this first note is clear to everyone. If you are multiplying the elements of any determinant with its own cofactor, then you will get the value of the determinant. Okay, so please note down this first note and note all these 4 points so that you will remember this. Okay, please note these 4 points.
Could you explain the last point?
Yes, in the last one, Shravya, what we have done, we have taken the elements of the first column. So A11, A21, A31. And we have again multiplied this with its own cofactor. So A11, A21, and A31. So as per this, okay, so as per this note, when you will add all these, you will again get the same value of the determinant.
Yes.
Okay.
So sir, any rows or any columns, sir?
Yes, any rows, any column, but cofactor should be its own.
Corresponding.
Corresponding cofactors. Okay, very good. So everyone, please note down this, confirm me, then we will check the second one.
Done, sir.
Then, very good. Everyone, please confirm me so that we can check the second note. Okay, Atif, good. Abdur, Mazia, Saf, please confirm if this is done. Okay, Mazia, very good. Abdur and Saf, please confirm. Okay, Abdur, very good. Saf, please confirm if it is done so that we can start the next. Okay, Saf, very good. Now the second note, okay. Second note is if elements of a row are multiplied with cofactors of any other row or column, then their sum is 0. Okay, I hope everyone understood this second point. If elements of a row are multiplied, so that means suppose we have taken the again the same determinant A11, A12, A13, A21, A22, A23, A31, A32, and A33. So if you have selected any row, for example, A11, A12, A13, now we are multiplying this with a cofactor of any other row. For example, second row cofactor A21, A22, A23. And if we will add it, if we will add this, then what we will get? We will get a 0. Okay, so everyone, this point is clear. The second one, if you have selected,
So if you multiply elements of a row with the cofactors of a column, will you get 0?
no, that
Should be row. It should be either rows or columns.
Rows or column. Okay, that will give a random answer. So if you have selected the elements of any row, then please select the cofactors of any other row, then you will get a 0. Okay, so this note 2 is clear to everyone. We will take one more example. For example, if we have taken the second row A21, A22, A23, And if you multiply this with A11, A12, A13, and if you will add it, okay, we have taken the elements of the first row, we have taken the elements of the second row, we have multiplied this with the cofactor of the first row, then we will get a 0. This point is clear to everyone?
Yes.
Okay, Shravya. Abdur, Mazia, Saf, the second point is clear? Okay, Saf. Okay, Mazia. Abdur,
Yes.
second point is clear?
Yes.
Okay, very good. Then please note down the second point. Note down this example. Okay, note down this and confirm me. Then we will start the next topic. Please let me know once it is done. After Eid, we will increase the time of our class. Okay, you will have a 2-hour class. Okay, Atif, good. Abdur, Mazia, Saf, Shravya, please confirm if it is done. Okay, Mazia, very good. Okay, Shravya, very good. Saf, please confirm. Abdur and Saf. Okay, Saf. Abdur, shall we start next?
Yes.
Okay. Now, next one. Just skip. Okay. Now, please find the minors and cofactor of the elements of the determinant. Wait. Yes. Find the minor and cofactor of the elements of the determinant and verify this. Okay, there's a very lengthy question, so just give me a minute. Find the minor and cofactor of the elements of the determinant of third row. Okay, so you need to find the minor and cofactor of the elements of the third row only, this one, and then verify this. Okay, so first of all, please find the cofactor and confirm me, then do the second point. Everyone, please start this question. Okay, Shravya, you get the first answer. M31. Okay, so M31 is what? This one, third row and first column. So you will get 0 minus 5. Shravya, will you please again check M31? So remove this third row.
Sir, it's minus 12.
Why? Okay, it is minus 12. Remove this one. Yes, you are correct. This is minus 12. And A31 is what? This 12. Very good. Then find the value of M32 and find the value of M33. Okay, Shravya. So M32, third row, second column. So this will give you 8 minus 30. So that is minus 22. Good. So this will, you will get 22. Very good. Uh, Shravya, there is M33. No, this is not minus 30. Third row, okay, and third column. So this you will get 0, minus and minus plus. This will you will get 18. There's also 18. And here, Shravya, this is M31. This is minus 12. Then A31 will also be minus 12. Okay, this one will also be equal to minus 12. Why? Because,
Got it, sir.
yep, that's good. Atif, Abdur, Saf, Mazia, please confirm if you are getting the same answer for the cofactor. And Shravya, please prove this one. Yes.
Sir, M3 will be minus 18, right?
Which one? M33. No, this
Yes,
is
sir.
plus 18. You will cross multiply these two and then
Okay, sir, I
minus.
got it.
Okay. Okay, Mazia, very good. Abdur and Saf, please confirm if you are getting the same answer. Yes.
So what's the point of verifying it? Because anyways, it's gonna be 0 according to the second rule.
According to second rule, yeah. That's why they will ask you in exam to prove this again.
Okay, sir.
Okay, Saf, very good. Abdur, please confirm if it is done. And then please start this point. Okay. Okay, Abdul, very good. So I hope all of you have completed this. Now please verify this point. A1
Verified, sir.
verified, very good.
Verified, sir.
Okay, Atif, very good. Mazia, Saf, and Abdul, please verify this point. Okay, Saf, very good. Now Abdul and Mazia, please confirm if it is done. M32, okay, Abdul. Abdul, for M32, third row and second column, okay. Just give me a minute. Okay. For M32, Abdul, third row, second column, okay, remove this one. Now multiply this. 4 into 2 is 8, minus 6 into 5 is 30. Okay, you get this one, 2654. So cross multiply, 4 into 2 is 8, minus 6 into 5 is 30. So you will get minus 22. Abdur, this is clear?
Yes, sir.
Okay, very good. Now Abdur, so A32 you will change the sign of this. So you will get a 22. Okay. Now, please put all these values in this equation, Abdur, and tell me the final answer. Okay. And Mazia, please confirm me if it is done so that we can start the next question. Okay, Mazia, very good. Okay, so now we will start the next one. Now, Next topic is adjoint of a square matrix. Okay, we know that what is a square matrix where the number of rows and number of columns are same. We need to find the adjoint of a square matrix. Now, what is the adjoint? The adjoint of a square matrix. Now, the first point is adjoint will exist only for the square matrix. Okay, so adjoint of a square matrix, this is defined as the transpose of the matrix, this one, where Aij is the cofactor of the element Aij. Adjoint of the matrix is denoted by adjoint. Now, we will discuss that what is the meaning of this one, how we can find the adjoint of a matrix. So first of all, we will form a matrix. A11, A12, A21, A22. Okay, so that means adjoint is also a matrix. Okay, minor and cofactor, here we get a determinant, here we get a single value. Adjoint will give you another matrix. Okay, so that means adjoint is also a matrix. Now, if you have this matrix A, then you can find its cofactor. Okay, so I hope everyone know that how we can find the cofactors. Here we will find A11, here we will find A12, here we will find A21 and then A22. So these are the cofactor of this matrix. Okay, now what is the adjoint of A? Adjoint of A, this is equal to transpose of this matrix. So that means from these cofactor, you need to form another matrix which have the elements A11, A12, A21, A22. First, you need to form this matrix, then you need to form the transpose of this. Okay, so this point is clear to everyone. If you get a matrix and you need to adjoint of that, so first of all, you will find the cofactor of all the elements. After that, you will write the cofactor over here, and then you will find the transpose of the cofactor. This is clear, Atif, Saf, Shravya?
Yes.
Okay,
Yes,
good.
sir.
Okay, Saf, this clear?
Yes.
Okay, so Saf, can you explain me how can you find the adjoint of a matrix? Saf, can you explain me how can you find the adjoint of a matrix?
By taking the transpose of the matrix.
Okay. Yes, transpose of which matrix? First, you need to find the cofactors, cofactor of all the elements. Then you need to arrange that cofactor in this matrix, and then you need to find the transpose of this. Then how can you find the transpose? This is equal to first row become the first column, second row become the second column. Okay, so I hope this is clear to everyone. Okay, just give me a minute. Okay, for example, this is a matrix, then its adjoint is equal to transpose of this one. Okay, this I have already explained to you that first you need to find the cofactor, you need to form a matrix, then you need to find the transpose of this matrix. So you will get this one. Okay, so I hope this topic is clear to everyone. Please note down this. Let me know if you have any doubt. Then we will solve a question on the basis of this topic. Please complete this. Everyone, please confirm me if it is done so that we can start the next topic.
Done, sir.
Okay, sure, we are good. Saf and Atif, please confirm me if it is done. Saf and Atif, this is done. Okay, Atif, shall we start next? Okay, done?
No, sir. 1 minute.
Okay. Next one. Please solve this question. Find the adjoint of this matrix. Okay, this is a very simple question. I will give you only 3 minutes for this. Please complete this question.
Sir, can you go to the previous slide? I didn't finish it.
Previous one. Okay, please note down this. This done, Seth.
Yes, sir, done.
Okay, good. Please try this question and share your answer. Okay, Atif, you get the answer. 4 minus 3 minus 1 and 2. Very good, Atif. This is correct. Shravya and Saf, please check. Are you getting the same answer? Very good, Shravya. This is correct. Very good. Saf, will you please confirm the answer?
I didn't finish it yet, sir.
Okay. Okay, Saf. Very good. Now, if we will check this solution, then this is our original matrix 2, 3, 1, 4. Okay, and this is the answer. So here, what they have done, if we will find a shortcut for this, for the matrix 2 by 2, then we need to replace this 2 with 4. So we get this 4, 2. And here they have put the negative sign. So there's a shortcut method for the square matrix 2 to find the adjoint. What you need to do, just interchange these two numbers, these two elements, and here just put a negative sign. Okay, but this is not of any use because you can't use this in exams. Okay, so but please note down this point. This is a direct method, but please do not use this in your exams. Please note on this and confirm me, then we will start the next topic. Everyone, please confirm me once it is done so that we can start the next question. Okay, Shrav, you are very good. Atif and Saf, this done. Okay, Atif, good. Saf, this done. Shall we start next? Okay, very good. Now we will do some theorems. Okay. The first theorem is if A be any given square matrix of order n. Okay, if A is any square matrix, then A into adjoint of A is equal to adjoint of A into A is equal to determinant of A into I, where I is the identity matrix of order n. We will do the proof of this. Okay. First of all, let A is equal to, first of all, assume that A is a matrix and these are the elements. A21, A22, A23, A31, A32, and A33. Suppose this is the matrix. Now adjoint of A, this is equal to what? Transpose of this matrix. Transpose of what? Just write the cofactors here. A12, A13, A21, A22, A23, A31, A32, A33, and find the transpose of this. Okay, so adjoint, we will get this one. Adjoint of A is equal to, find the transpose of this. First row become the first column. A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, this we get the adjoint. Now, what's the theorem? If you're multiplying the matrix A with the adjoint of A, then this will be equal to what? A, we have this matrix A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, into this one. This is A11, A21, A31, A12, A22, A32, and this is A13, A23, and this is A33. Okay, now we will check that what the answer we will get if we will multiply this one. So here we will get A into adjoint of A. Okay, and this is equal to, we will multiply the first row with the first column. A11 will get multiplied with the cofactor A11, A12 with this, A13 with this one, and we will add this. So anyone can tell me the answer? If we are multiplying the first row with the first column, then what the answer we will get? I will give you the hint.
0.
No, sir, this is not 0. I will give you the hint. This is based on the previous two nodes. Okay, this is not 0. Saf, please again try this. First row, first column.
What is the determinant of A?
Determinant of A. Saf, is this correct? Okay, Saf, first row is the element of first row. If you will check the first column, then this is the cofactor of the first row because we have done the transpose over here. So, Saf, can we say that we will get a determinant?
Yes, sir.
Okay, Shravya, this is clear?
Yes, sir.
Okay, then Shravya, can you tell me the second one? If we will multiply the first row with the first row, second column. Shravya, first row, second column, which will give you what? Shravya, you are multiplying the first A11, A12, A13 elements with the cofactor A21, A22, A23. Then what the answer you will get? Shravya,
Determinant of A.
determinant or 0?
That is 0.
0. Okay, because this is the element of first row and these are the cofactor of the second row. So this is 0. Saf, can you tell me the third one? First row, third column, if we are multiplying, then what the answer we will get?
A11, A31.
So this
Plus-
is, yes, A12, A32, A13, A33. So what will be the final answer if we will add all these terms?
0.
0. Because these are the element of the first row, these are the cofactor of the third row. So 0. Similarly, second row, first column, you will get a 0. Here you will get a determinant. Here you will get a 0. Again, 0, 0, and determinant by the same logic. Okay, 0 we will get because we are multiplying the elements of any other row with the cofactor of any other. Now, A into adjoint of A. This is equal to. This is equal to. Now, from the matrix, you can take anything common. Okay, if there's anything common in all the elements, then you can take out that common. So from all these, we can take the determinant of A common. Okay, so this and this element, we have the determinant of A, but from the 0, we can take out anything common. So that's why from the complete matrix, we have taken determinant of A common. So we will get 1, 0, 0, 0, 1, 0, and 0, 0, 1. Okay. Now, Saf, can you tell me what is this? 1, 0, 0, 0, 1, 0, and 0, 0, 1? Yes, Shravya, you are correct. Saf, what is this? Which type of matrix is this? Saf, which type of matrix is this? 1, 0, 0, 0, 1, 0, 0, 0, 1. Saf, is this not an identity matrix?
It is, sir.
It is. Okay. So we get this one. And the same thing which we need to prove over here, that A into adjoint of A is equal to adjoint of A into A is equal to determinant into R. Okay. So I hope this is clear to everyone. Please note down this and let me know if anyone have a doubt in this. Okay. Then we will check the second theorem. Please note down this. Please confirm me on the chat box once it is completed. Okay, Shravya, very good. Atif and Saf, please confirm me once it is done. Okay, Atif, good. Saf, please confirm if it is done. Okay, Saf, very good. Now next one. Next is second theorem. If A and B are non-singular matrices of the same order, so what's a non-singular matrix, Shravya? What is mean by non-singular matrix? We have already done this. Sorry,
Not sure.
you're not sure. Okay. Atif, what is mean by non-singular matrix?
A matrix whose determinant is non-zero.
Very good. Okay, so a matrix whose determinant is not zero is a non-singular matrix. Okay.
Sir, I wasn't there. So
Sorry, Shravya.
I wasn't there, so
Okay,
I
okay. Okay. Then, Shravya, you can take the recorded lectures of this chapter.
yes.
Okay. Okay, so if A and B are non-singular matrices of the same order, then AB and BA are also non-singular matrices of the same order. So what does this mean? Suppose if we have a matrix A whose determinant is not equal to 0. Similarly, matrix B, determinant is not equal to 0. Then if you will multiply AB, then the determinant of AB is also not equal to 0. If you find out BA, then determinant of BA is also not equal to 0. Okay. So I hope the theorem 2 is clear to everyone. If A and B are two non-singular matrices of the same order, then if you will multiply them, A and B, then the resultant what you will get will also be a determinant which is not equal to 0. This is clear? Theorem 2?
Yes, sir.
Okay, very good. Then please note down this theorem and confirm me. Now we will end our class. We will continue this topic tomorrow. Okay. Today you don't have any homework. Please complete your previous homework. Okay. Please note down this theorem and then we will end our class. Okay. Please let me know if it is done. Okay. Mazia, you have just joined. Please take a screenshot of this this slide. Okay, Mazia, we will continue this topic tomorrow. Okay. Okay, Saf. Good. Okay, Atif, I hope you have also noted down this one. Mazia, please take the screenshot of this. Okay. So today there's no homework. Please complete your previous homework. We will continue this topic tomorrow. Okay. Okay then.
Thank you, sir.
Thank you. You're welcome.
Thank you, sir.